Okay, so looking at the 1.2 notes, it's like Inception. Looking at the 1.2 notes, where are they at? What am I doing right now? That's being recorded. I want to share my screen. Here we go. Got it. Okay, I think we're ready now. Perfect. So I just want to talk about the extrema thing again, just to make sure that we're all on the same page. Like I said something different to the 3 different classes. Actually, I think it was one class. I said something a little bit different. Just want to make sure we're all on the same page. And to make sure that we're staying consistent with what Mr. Schneider will tell you in calculus next year, I sat down and talked with him for a little bit too. And the funny thing is we have a calculus textbook right now that is getting kind of old. So I have a new version that I ordered that I've been looking at. He ordered a new version of a different type. And this is one of those things that in all 3 books, it says something a little bit different about how to handle this. So we kind of said, all right, here's what we want to be kind of consistent. First of all, what I had you guys write down here in green, that endpoints are not considered relative extrema. If you didn't write that, make sure you write that. We're sticking with that. Because of the definition of relative extrema. Now remember, relative and local mean the same thing. Extrema is a fancy way to say minimum or maximum. Extrema covers both those words. In order to be a relative extrema, it has to be, let's start with the word maximum. In order to be a relative maximum, it has to have a y value that is higher than the y values on either side of it. Oh, yeah, leave that in there.
Okay.
Thank you. So in order to be a relative maximum, it has to be the highest y value or have the highest y value compared to points on both the left and right of it. So if it's an endpoint, that doesn't fit that definition because it's only higher or lower, if we're talking minimum, than points on one side of it. So we are going to stick with the idea that endpoints are not relative extrema. Now they can be considered absolute extrema, but not relative extrema. Another thing that he brought up that I've never even thought of or mentioned is that, you know how we said you could use the words local or relative, it means the same thing, right? You're going to see both. You can say either one. I don't care which one you use. He said that there is another word you're going to see in calculus that means absolute, and that is global. So I'm going to write the word global next to absolute so that you get used to seeing that one too. He said that one is more common in the AP Calc once you start looking at AP Calc test resources and whatnot. So thought that was a good thing to throw in there. And now, I don't know if I said this or not or what I said about absolute maxes and minimums are also considered relative mins or maximums as well. You don't have to list that every time. Like if I asked you, what is f of e? If that was the question, if I said, what is f of e? And if you said, it's the absolute maximum, you are correct. We're done. We're all in agreement with that, okay? However, if I said, list all the local maximums here, you would include f of e as a local maximum because it could also be considered a local maximum. Does that make sense? It's getting kind of picky, but I just want to make sure that you're okay with that. Yes.
So a local maximum can also be the maximum.
Yes. The absolute or global maximum. Yes. Other questions? Okay. So, we do have some people joining us now. Awesome. Hey, if you guys that are joining us, somebody just left. They had enough. They were already done with what we were doing. But if whoever's left there, if you can tell me if you can hear me or not, just by typing in the chat, that is really helpful because sometimes stuff is funky. So let me know if you can hear me. Oh. I got a yes. Okay. All right. Good. Sweet. So every class I've had multiple people joining us, live streaming, okay, which is way easier for me to do than trying to keep up with recording videos. To do both live streaming and recording has been almost impossible. It's too much for this computer to handle all at one time. I'm trying it. I think I'm doing it right now. I'm recording it with that computer, going to see if that works. But I've had enough issues with this computer today as it is. Halfway through just live streaming in the last class, everything decided to stop working. So if you get quarantined and you just want to watch some recorded videos, you're probably going to be out of luck, because I do not have time to sit and record 3 40-minute videos outside of classes. It's going to be mostly live streaming now. Now there are notes keys, so if you get stuck at home and you're like, I don't really want to live stream today, or I can't live stream, there might be times that I tell you you need to live stream in, but if you can't, or for whatever reason, you could use the notes keys just to fill out notes that are on Classroom and use that to do your notes. But I cannot make any promises about recorded videos. So little after school message there. All right. Do you guys have any questions on 1.2 at all? We basically finished the notes. I don't think in this class we got through those 2 examples, but I'm totally fine at that. If you really want to look at those examples, there's a very short 3rd video in 1.2 that it took 2 minutes to go through those 2 examples if you want to take a look at them. But we did finish the rest of this stuff. Actually, we didn't do 10. So as long as you're here, let's finish example 10, because it's a reminder of that limit notation. Nice little warm up for today. So what this is asking you in example 10, does everybody see where we are? Okay. What this is asking you is, let me see if this is working for me. Ooh, we're back. All right. See, that was writing over there before. Microphone didn't work. So what it's asking you in example 10 is to rewrite this stuff as limit notations. Okay, so we're going to do that first. And then we're also going to draw a graph that represents those same things. All right, so I'm going to change actually that to blue. I'm going to do the top one in red and that bottom one in blue here. So take a second to see if you can finish that limit notation. Actually, it's really not that hard, is it? Once you get used to the limit notation, it's just knowing kind of how to write it. That limit as x approaches positive infinity of f of x. This is saying it should approach negative infinity. So then we'll just say approaches negative infinity. Okay, now I got one really quick thing. Another thing about being consistent. This thing that was sitting here already, why did that? I thought I turned that blue. Okay, this thing that is, whatever. The stuff that was sitting there had these arrows right here, right? I used to use arrows if it was approaching infinity or negative infinity, but equal signs if it was approaching a value. In the last 2 years, I've just switched to completely doing equal signs. They're all fine. You can use whatever you want. I'm going to start when I make my limit notations. I'm just going to leave these the way they are, because I'm going to just always start using equal signs. So this one is approaching positive infinity. As we're going left, we're approaching positive infinity. That says as you're going left, you're approaching positive infinity. So they all say the same thing now. Now, what sort of graph would this look like? Well, as we go right, it goes down. As we go left, it goes up. So as long as it's doing that, it doesn't matter. If you want to make it just a simple cubic sort of thing like that, if you want to get a little more interesting and put some curves in it, some turns, you can do that as well. And then those of you that are following along at home, if you just want to type any questions that you have in the chat, I can usually catch that out of the corner of my eye, and then we'll try to answer them as well. David kept us busy yesterday with his questions, man. It was awesome. Yes?
So I feel a little bit confused. How do we know it was a cubic function?
I don't. It's just saying, okay, so the question was, in case couldn't hear it, how do you know it's a cubic function? All we know is it has that end behavior with, where'd it go? All we know is that it looked like that. And what I'm telling you is you can draw whatever you want to on the inside there. So if you want to be a little more interesting and do that, you can do that. But it's just got to match that end behavior. So the next one says, as we go to the right, ooh, that one go right first? Yeah, it did. This one says, as we go to the right, the function goes up. That's what that top line says. As we go right, the function goes up. So we're going to write that right here. As we go to the right, at the limit of the function as x approaches positive infinity is going to be positive infinity. So I've got something like that. That's all I know right now. Then it says, as x approaches negative infinity, the function is going to actually approach a value of 0. And this is where I used to, because it was a value, I use an equal sign. I've started to always just using equal signs now. So you'll see equal signs in pretty much all my limit notation on some of the stuff that you look at. So I know that it's got to approach 0. When it's approaching a value, that means that there's a horizontal asymptote then at 0. So this thing must look something like this, some sort of maybe exponential function. All right, any questions on that at all? So here's a nice thing about 1.3, especially if you're at home, is we're not going to be doing a ton together here. There's going to be a lot of work time on even filling the notes out. Why did I switch? There we go. What you need to do is find your notes. Now, I do have an issue, though. Mine that I thought I put in here, I thought is the same stuff you have. You actually have an updated one that I made, I think, last year. And yours is better. Yours is better because it actually has the name of the functions. Like this one says linear or identity, right? I'll just write linear. So you have this already there. And you also have a spot down here that says equation. So that's where you're going to be writing the equation. So the linear equation is y equals x. That is the base equation for all linear functions. Okay, every line can come from that thing. That's why sometimes we refer to it as the parent function, because all other lines can come from that function. Those 12 functions there are specifically called, and the ones we're putting here, the 12 basic functions. So you'll kind of hear me say base function and parent function interchangeably. Then what you're going to do is you're going to graph that y equals x here. Now, we specifically want you to graph that line, y equals x, which is the line going through the origin with a slope of 1. So it looks like it's at that 45-degree angle. And then what you're going to do, and you're going to do this for all 12 functions, is you're going to fill out all of this fun information that we just talked about in section 1.2. Now, it doesn't say this on yours, I don't think. Oh, yeah, I did put it on there this year. I hand wrote it. 1.3. These are your 1.3 notes. Okay? Now, it's not as bad as it looks. Strawn, it's going to be okay. It's not as bad as it looks, all right? So let's take a look at this guy. Domain, range. What's the domain and the range of the linear function? All real numbers. Good. So we're just going to go, x can be anything from negative infinity to positive infinity, and so can y. Awesome. There's only 3 things we said that affect domain in the last section. Fractions, can't divide by 0. Radicals are even roots. You cannot have a negative under an even root. And logarithms. This has none of those things going on. The domain is all real numbers. Now, we didn't talk very much about range, but if you've gotten through some of the 1.2 notes, there is a section about range, and I will say this about that section. Use your graph calculator to help graph those things, and then use the graph to say what the range is from bottom to top. That's a little review from last year about just looking at a graph and going, what's the range coming out of it? These functions right now, we have not talked about how algebraically, just looking at it, you can get the range. So use a graph for those. Okay. Does this thing have any discontinuities? No. What were the discontinuities we talked about? Do you remember? Just shout them out. Holes, jumps. The big one, the main one that we use, vertical asymptotes. Vertical asymptotes. Something, I heard asymptotes, right? Those are the three discontinuities. This thing has none of them. So you could just write the word continuous, really. I'm going to be a little bit more specific. I'm going to say it's continuous on its entire domain, but I'm just going to say continuous on the x values from negative infinity to infinity. That's a little redundant, but I'm the teacher, so I want to make it look nice. So increasing, decreasing, you're basically going to list where is it increasing, where is it decreasing. What would you say about this thing? It's as easy as you think it is. DeWalt, what would you say about this function? About it increasing or decreasing. Where is it increasing? Okay, so increasing means it's positive. So he said from quadrant 1, right? What about over here? Is it increasing? Go from left to right. From left to right, is this thing going up? Yes, he's nodding yes. You can't see it, but he's nodding yes. So this thing is always increasing, right? It's always increasing. So a couple things to remember. When you're talking about increasing, decreasing, you should always be talking from left to right, okay, with the function. All right, so I think what he did at first, and I think a lot of us do this sometimes, is we start in the middle and we go, well, as I go this way, it's going up, but as I go that way, as I go to the left, it looks like it's going down. But remember, the whole thing going from left to right. So this thing's always increasing. So I'm just going to say increasing, again, on that entire domain. On that interval from negative infinity to infinity. Yes?
Okay, so we're filling this out. I think you said we were going to do a lot of it on our own. Are we just basing like the increasing off of the parent function?
Just the parent function, just this base. Because what Taylor's getting at is, what if you had a line that was going with negative slope, right? What if you had a line that was horizontal? This is only talking about that base function. Good question. Okay, symmetry. Could you fold that thing over the y-axis? Over the y-axis? No. So it's not. What is it not? Do you remember what we said about symmetry, the different types of symmetry? Yeah. It's not even. Edric coming in clutch in the back. You guys can't see that, but he just threw a guy out at home. All right. It is not an even function. Even functions can be folded over that y-axis. Odd functions are reflected over the origin. Does that thing look like it is reflected over the origin? Yes, it is. Okay, let me give you a little thing about odd functions. I didn't say this the other day, but maybe this will help. Odd functions are symmetric over the origin. They look the same if you turn the paper upside down. So if you literally took your paper right now and turned it upside down, doesn't the function look exactly the same? This is an odd function. So all you got to do is write odd. It's symmetric over the origin. Boundedness. We said functions could be bounded below if they had like a floor or a minimum. Bounded above if they had a maximum or like a ceiling. Or if they were bounded both above and below, we would just say they were bounded. Okay? This thing is not bounded at all, is it? You could write none. You could write unbounded. Or just write none. I think in the other classes I wrote none. That really doesn't matter to me. You just write none too. How about local extrema? Are there any relative or local extrema? No. None. Now, let me just throw this out there. This is where, even if it had an absolute extrema, you would write that there because they're considered local as well. All right. But by them putting local, you have to list everything, local including the absolute. Are there any horizontal or vertical asymptotes? No. None. Nope. Whatever. End behavior. Limit notation time. As we go left, where does this function go? To negative infinity, right? Down. So the way you write as you go left is the limit, and then really small underneath, as x approaches negative infinity. Now, let me show you something right away. What have we normally been putting right there? F of x. Good, you've been paying attention. Another thing you can do is if you know what the actual function is, our function is y equals x, right? You can actually put that function here, x. And it looks weird here because the only thing is just that variable x. But if it were the square root function, you put the square root of x. If it were the quadratic function, you could do that. A lot of times you'll actually see the function limit written in that limit spot. You can either put f of x or you can actually write what the function is, which is just x in that spot as well. And this is going to equal, as we go left, it goes down, negative infinity. As we go right, it goes up. So I'm going to write the limit as x approaches positive infinity of x, or of the function f of x, equals positive infinity. What's your next function? Quadratic. Let's real quick, I know you guys know what the quadratic is, but let's real quick come down here. Now remember, you're drawing the base function, so don't just put any old quadratic function in. This is the granddaddy of them all. This is the 001124. Can't really fit 39. We'll reflect those over. Okay, and then we'll draw a nice graph in here. Looks really nice. Okay. So what's going to be different about this thing compared to the line? I know obviously it's a different function, but how about boundedness? Is this thing bounded at all? Yeah, bounded where? Below. It's bounded below. And you don't have to write why or where because you're about to do that in local extrema. It has a minimum, right? So you could write, I'm even going to write that it's an absolute min at, now there's two ways you can give minimums. Either give the point or just give the y value. Well, in this case, x and y are the same thing. It's the 0.00, right? But that is one thing that students struggle with when we get to the quiz. I'm telling you right now, you'll be asked about local extrema, and people will give the x values of the local extrema. Local extrema, the max and mins are the y values because you're talking about the y value being the highest or the lowest. How about symmetry? What type of symmetry is this one? Even, right? How about continuity? Is this thing ever discontinuous? Nope. You can just write continuous. The domain and range, I'll let you take care of that. Increasing, decreasing is the one I want to talk about. So from left to right, you're looking from left to right. So it's like I'm coming down here. I am decreasing until I get to 0, right? So here's what I'm going to write. I'm decreasing from negative infinity to 0. Personally, I think a parenthesis makes sense there. Depending on which resource you look at, this is one of those things where you may see a bracket. I will not mark off if you put a bracket. I'm just telling you I think it should be a parenthesis. And that was something that Mr. Schneider agreed with me on. Probably makes more sense to have a parenthesis. And the reason is because now if you say where it's increasing, which would be okay if I continue on. Now it's continuing on and increasing until it gets to positive infinity. I'm going to say it's increasing from 0 to positive infinity. I don't want to put a bracket on that 0 because if I put a bracket on both those zeros, you're saying it's both increasing and decreasing at 0, and it just sounds weird. So I like to use a parenthesis to say that it's really not increasing or decreasing at that spot, okay? Because that's a minimum. It's changing from from decreasing to increasing, all right? The derivative at that point would be 0. Okay. Have you guys heard that word derivative before? Have you ever heard derivative? If you haven't, you're going to hear more and more of it through this year because that's a calculus thing. We're going to get into derivatives. Okay, so we kind of mentioned some of that other stuff. End behavior, I think you can get that, right? You go left, it goes up. You go right, it goes up. You could actually write that with one limit if you wanted to. I'd be okay with that. Any asymptotes for this one? No. So you're already two done here. You're already done with 2 here, I should say. I know if you guys are at home, you don't have this sheet because I just handed it out. I decided to give us a sheet that has, is that what your front side looks like? Yeah. So on the front side, it has that. And on the back side is just basically a reminder of what you should know how to find, like some symmetry, continuity, just I don't really know what the point of the backside was. I had a backside, so I thought I should put something on it. Otherwise, I felt like I was wasting paper. So there's that. But I thought it'd be nice for you to have a sheet that had all the functions on it. Some of you are fortunate. You sit really close to the yellow posters there that you can just use those, but not everybody can do that. Now, if you ever lose this, or if you're at home so you don't have this sheet, it's actually on Google Drive. If you go to Classroom, I think it is one of the resources that we have. Uh-oh, I think I might have lost something there. Let me go to Classroom real quick. Classwork. And if you go to the Student Materials folder, and then if you go to, wait for it, the chapter that we're in, which is chapter 1. And then if you go to Notes Keys, I got 2 resources here, Resource 1 and Resource 2. One of them is, it's not that one. It's a little bit better, actually. This one has all the answers to your notes. Like if I zoom in, you can see it says stuff like, here's where it's symmetric, here's where it's, whatever. So I put that in Classroom, and I don't want you to copy all this for every single one of these. I think you should go through these and try to do what you can and leave things blank that you don't know. And then go to either this, or I have an actual notes for a key for the notes that looks just like the ones you have that you can look at too. But I'm glad this one popped up because I'd like to show you something. Look at what they say about increasing, decreasing. I can't highlight it, but they use the bracket on the 0. So I'm telling you, I can't mark you wrong because I have a resource I'm giving you that uses a bracket. I'm just telling you that I wouldn't use a bracket. Okay, so I would not mark you wrong for that, like on a quiz or something. But there's some gray area with certain things. Other things there is not. Like what did I just say before? Extrema. If you're asked for the maximum or minimum, give the Y value. When you ask for intervals where it's increasing or decreasing, those are X values. So here's what you're doing for the rest of class. You are working through this set of notes. Okay, I will put a notes key up here if you want to check some things every once in a while. Personally, if I were you, I would grab a Chromebook at some point in time and just pull open this or the actual notes key that's on Classroom, which you can get right to from the classwork page. Notes, chapter 1 notes, chapter 1 notes keys. It's right in here somewhere. Where are you at? Here's that 1.2 beast of a section. 1.2 and 1.3 are, I think, the 2 longest sections we do for quite a long time. So then you can open this up to see how I've done certain things, all right, and to clean up some notation. And there's certain things you're going to fill out on here, like where sine and cosine are increasing and decreasing. Let me just throw that up here. Where sine and cosine are increasing and decreasing. Look at how that's written. You know what? You might not quite understand that right now, and I don't care. I just want you to write that down for right now, okay? I'm not going to ask you to give these intervals or increase, decreasing. That, and then look at the absolute, relative, extreme. Write it down for right now. We'll talk about it a little bit, but I won't ask you to write that like that on the quiz, okay? Your quiz is going to be more like what the homework is, and that puts me into the second thing that I want to say here. So with the time that you have remaining here, which is, 50 minutes almost, 50 minutes, I would work on this, but then at a certain point, I would shut this down just to change pace a little bit, and I would pull out the worksheet and work on that instead. Or I had some people start with the worksheet, and then they worked on the notes later. I really don't care, to be honest with you. I just want to show you on the worksheet. This is what the worksheet looks like. It gives you, now those aren't, to start with, those are not the 12 basic functions. They are the 12 basic functions like transformed somehow, shifted, reflected, something. But you're still matching those graphs, those letters, with problem 13 through 18. Okay? And then, this is from a class yesterday. We just looked at this and somebody said, how do I write my answers for numbers 19 through 28? And I said, just write the functions. So there's the answer, number 18. Which 4 functions are odd? Linear, cubic, sine, and inverse. Or what else is that called? Not inverse, reciprocal. I think there's another word too. We'll just go with reciprocal or inverse. but just write the function like that. So work on the notes, work on the worksheet, bounce back and forth. I don't care. Grab a Chromebook if you want it sometime to help you fill out the notes. Question?
How can we work with other people?
Yeah, absolutely. In fact, I'd be upset if you weren't doing like the notes with other people. Because to me, as you're going through, you're like, whoa, what do you think about the increasing on this function? It's better if you're talking to people about it. So I shouldn't say I'd be upset. Now, obviously, try to like not breathe down each other's throats, keep your masks on, and be smart about how you're working. Okay. God, I hope 5 years from now, if somebody's watching this video that I'm recording, they're like, what are they talking about? Okay. 2020, you have no idea. All right. So you were just a little seventh grader, probably. All right, it's getting weird. So I'm going to shut this down. Anybody at home, they left a long time ago. They were out. They couldn't take it anymore. All right, we're going to shut this down. It's been fun.